Imagine this. It's a crisp autumn night in October 2025, the kind where the stars seem to pierce the sky like diamonds on black velvet. In a modest basement in Ohio, USA, an amateur radio operator named Alex hunches over a glowing screen. The hum of his software-defined radio, SDR, filling the room like a distant heartbeat. He's no stranger to the night sky's secrets. Years of scanning frequencies, chasing faint signals from distant galaxies, all fueled by a passion that's as old as humanity's gaze upward. But tonight, something extraordinary cuts through the static. A sudden spike at 1,420.40575 megahertz, the hydrogen line. That sacred frequency where the universe's most basic element hums its eternal song. Alex's heart races as his eyes lock on the waterfall display, a cascade of colors representing the radio spectrum. The signal is narrow, barely wider than a whisper, yet it stands out like a lighthouse in a storm. Time-stamped at 2:13 UTC, it's aligned perfectly with Andromeda's coordinates. Azimuth 38.2 degrees, elevation 61 degrees. He checks for local interference. No nearby cell towers buzzing, no appliances humming falsely. His hand trembles as he logs it, then jumps on a Discord call with fellow enthusiasts around the world. Anyone else seeing this? His voice is clipped, urgent, laced with that electric mix of excitement and disbelief. Little does he know, this is just the beginning. A cosmic riddle that's about to unfold across continents, pulling in souls from diverse walks of life, all united by the thrill of the unknown. 6 hours ahead, in the bustling heart of Berlin, Germany, another operator, Lena, a software developer by day, tinkers with her home-built receiver in a cluttered apartment overlooking the city's twinkling lights. The same frequency ignites her screen, the phase and drift matching Alex's trace to the millisecond. Lena's mind races through scripts she's written herself. Fast Fourier transforms scanning for patterns. She cross-checks with archived satellite passes and radio frequency interference RFI logs. Nothing fits. The hydrogen line is protected by international law, a quiet sanctuary in the electromagnetic spectrum. She overlays UTC, frequency, and signal-to-noise ratio SNR in a screenshot, posting it to the shared forum. Confirmed, not local, not a known artifact. Her pulse quickens. This isn't just data. It's a bridge to something profound, stirring emotions of wonder and a subtle undercurrent of unease. Down under in Melbourne, Australia, in a radio room tangled with cables and lit by the soft glow of monitors, Raj, a retired engineer turned stargazer, waits for Andromeda to crest the horizon. His setup is humble, a battered logbook, maxed out SDR gain, but his dedication is fierce. At 13:14:59 UTC, the spike appears, faint but identical, just above 10 degrees elevation. Disbelief hits first, a muttered curse under his breath, then frantic verification. RF, iDatabases, weather logs, all clear. He uploads his raw data and joins the Discord call. That's 3 continents. Same event. This isn't us. The words hang in the virtual air, binding these strangers in a shared destiny. From Ohio's suburban quiet, to Berlin's urban hum, to Melbourne's starry outback, the signal echoes, a universal call that transcends borders, cultures, and languages. Within 90 minutes, the Discord channel explodes with life. Screenshots, logs, raw IQ files pouring in like a digital torrent. Operators compare antenna patterns, system temperatures, calibration notes. The initial thrill bubbles with laughter and high fives over voice chat, but beneath it lurks a shadow. A sense that this signal, this cosmic intruder, wasn't meant for casual ears. It's as if the universe itself has leaned in close, whispering secrets that could reshape everything we know. And you, dear viewer, are right here with me in this story. Feel that chill? If this hooks you as much as it does me, smash that like button and share it with a friend who's ever stared at the stars wondering if we're alone. Let's dive deeper together. As the night wears on, the group's voices shift from excitement to focused determination. Alex in Ohio sketches quick diagrams of his dish setup, sharing how the signal pierced the noise floor like a needle through silk. Lena in Berlin runs simulations, her code unraveling the signal's purity, evoking memories of childhood stargazing in the German countryside, where the Milky Way felt like a personal promise. Raj in Melbourne, with his decades of experience, adds historical anecdotes from his youth in India, where ancient myths of celestial messages fueled his lifelong pursuit. These personal layers weave into the data, making the mystery not just scientific, but deeply human, relatable to anyone who's ever felt small under the vast sky. The emotional depth hits hard. Alex thinks of his late father, who introduced him to radio astronomy, wondering if this is a sign from beyond. Lena battles imposter syndrome, her developer mind questioning every line of code, yet feeling empowered by the global collaboration. Raj reflects on life's fragility, the signal reminding him of humanity's fleeting place in the cosmos. This isn't just about waves and frequencies. It's about connection, curiosity, and the raw fear of the unknown. Transitions smoothly now to the next phase. As the data piles up, the hunt for confirmation begins, turning casual hobbyists into unwitting guardians of a galactic secret. The Discord channel, once a casual hub for radio buffs, transforms into a virtual war room buzzing with energy. Screens fill with waterfall plots, vibrant rivers of color mapping the signal's path, and UTC-stamped logs that align like stars in a constellation. Operators from Ohio, Berlin, and Melbourne upload their raw IQ files, each paired with meticulous calibration notes and antenna diagrams. The first priority? Rule out terrestrial interference, that sneaky culprit that has dashed hopes before. They scrutinize GPS-disciplined clock traces, ensuring timestamps sync within fractions of a second, like synchronized dancers on a global stage. Environmental telemetry floods in, temperature readings from humid Ohio basements, humidity levels from Berlin's rainy evenings, even local RF noise from Melbourne's suburban sprawl. Each site's antenna log details azimuth and elevation, proving dishes were locked onto Andromeda as it rose like a celestial phantom. In Melbourne, the signal arrives hours after the others, mirroring the galaxy's lazy arc across the southern sky, a delay dictated by Earth's spin. This staggered detection strengthens the case. No satellite, no aircraft, no earthly emitter could mimic such precision. A volunteer in Tokyo, monitoring from afar, dives into NASA's latest satellite catalog as of October 2025, cross-referencing every potential interferer. Nothing matches. The signal stands defiant. A shared spreadsheet blooms like a digital garden, rows filling with UTC times, SNRS, dish sizes, system temperatures, and operator notes. By day's end, over a dozen independent logs confirm the narrow spike at 1420 MHz, drifting only as expected from Andromeda's radial velocity, currently measured at about 110 km per second toward the Milky Way, according to the latest astronomical data from 2025. Geolocation filtering becomes the unofficial protocol. Only detections with the galaxy above 10 degrees elevation and matching Doppler corrections count. The pattern holds from Germany's urban fringes to a sheep farm near Melbourne, layering evidence like bricks in a fortress. The chat, once lighthearted, now mirrors a scientific journal, operators double-checking calibrations, sharing Python snippets for analysis, debating data packaging for external review. The teamwork pulses with energy, a global symphony where diverse voices harmonize. Alex's Midwestern pragmatism, Lena's European precision, Raj's Asian wisdom. Emotions run deep, pride in their amateur status, anxiety over the implications, joy in collaboration. Imagine the thrill. Strangers becoming allies overnight, bound by a signal from 2.5 million light-years away, a distance so vast it humbles the soul. As the evidence mounts, speculation creeps in. What if this is it? Alex types, his words carrying the weight of generations of dreamers. Lena responds with the emoji of wide eyes, her heart pounding with the same mix of awe and trepidation that has driven explorers throughout history. Raj, ever the elder statesman, urges caution but can't hide his excitement, reminiscing about Diwali nights under starlit skies, where lights symbolized hope. This chapter's tempo builds, from quiet detection to fervent verification, energizing you to keep watching. If you're feeling that pull of mystery, drop a comment below. What's your take on signals from space? Like and share to spread this cosmic tale. Deeper into the night, the group expands. A teacher from Brazil joins, her small rooftop antenna catching a faint echo. A student in South Africa uploads data from a university club setup. This global tapestry makes the story relatable. No matter where you are, from bustling cities to remote villages, the sky unites us. Emotional layers deepen. The fear of misinterpretation, the hope for discovery, the shared humanity in facing the infinite. Fluidly now, as the data solidifies, a pattern emerges, pulling us into the heart of the riddle. With the signal's extraterrestrial origin all but confirmed, the real magic begins. Decoding. Raw IQ files feed into custom, fast Fourier, transform scripts, written by hands trembling with anticipation. Alex, the retired engineer in Ohio, crafts a simple Python program to hunt for repetition in the pulse stream. He counts 1,679 distinct pulses, spaced with eerie regularity. The number leaps out, factored into 23 and 73, both primes, echoing the grid of the 1974 Arecibo message, humanity's own cosmic postcard. Posting his findings, Alex ignites a firestorm. Lena in Berlin overlays the sequence into a 23 by 73 grid, birthing a binary bitmap from the chaos. The image materializes, a crude spiral on the left, its arms curling like a galaxy's embrace, while dots and dashes border the edge. Some spot atomic numbers: hydrogen, 1, carbon, 6, nitrogen, 7, oxygen, 8, phosphorus, 15, the building blocks of life, as if the sender is saying, we are made of the same stardust. A tight cluster near the center defies randomness. Perhaps mimicking DNA's helix or a viral structure, shapes universal in biology. The group shares screens in real time, voices overlapping in excited debate. Look at that spiral. It's not Andromeda exactly, but a symbol, Raj points out, his tone laced with wonder. Emotions swirl. Awe at the mathematical elegance. Fear that this intelligence mirrors our own too closely. The resemblance to Arecibo is chilling. Did they hear us? But Andromeda's distance, 2.5 million light-years per 2025 measurements, shatters timelines. The signal left before Homo sapiens evolved, a message from ghosts. Speculation deepens the narrative. Is the cluster a warning, a greeting, or a blueprint? Operators flag hypotheses, aware of pareidolia's trap, seeing meaning in noise. Yet the universal logic, primes, elements, geometry, feels intentional, designed to bridge alien minds. Alex feels a paternal pride, Lena an intellectual high, Raj a spiritual resonance with ancient Vedic cosmology. This chapter's rhythm quickens, building suspense like a thriller's climax. If this decoding thrills you, hit like and comment your interpretation of the pattern. Share with space enthusiasts worldwide. Let's decode together. As interpretations multiply, the physics of such a feat looms, transitioning us to the impossible scale. A signal from Andromeda isn't just a puzzle, it's a defiance of physics. The gulf spans 2.5 million light-years, about 2.37 times 10 to the 22nd meters, where free space path loss at 1420 megahertz hits a staggering 486 decibels. For context, Earth's mightiest radars fade to nothing across fractions of that distance. An isotropic broadcast would demand energy on a stellar scale, 90 quadrillion gigawatts, implausible even for advanced civilizations. But beam it tightly, and the math shifts. A city-sized or planetary phased array could focus the energy, dropping power needs to thousands of megawatts, feasible for a Type 2 civilization harnessing a star's output. The beam must target our solar system precisely, surviving intergalactic drift. On our end, amateur dishes, 2 to 6 meters, strain to catch it, pushing limits only professionals usually touch. The odds daunt, yet the structured message suggests intent. Repeating, encoded for detection. Excitement shadows with reality's indifference. The universe doesn't cater to curiosity. Operators grapple emotionally. Alex ponders humanity's insignificance. Lena calculates probabilities late into nights. Raj draws parallels to epic journeys in folklore. Recent 2025 studies, like those in Nature Astronomy, add layers. Andromeda's approach at 110 kilometers per second, now with only 50% collision odds in 10 billion years, making the galaxy's future as uncertain as the signal's meaning. Before whispers become shouts, verification reigns supreme. SETI post-detection protocols demand archiving raw data, logs, metadata for independent teams. Each must replicate using varied software, hardware, confirming frequency, timing, modulation, no artifacts allowed. The checklist exhausts: GPS clocks, antenna alignments, telemetry, null sky frames, RFI catalogs. Professional observatories get notified, but time is precious, justified only by ironclad evidence. Amateurs submit via liaisons, embargoing public release to shield from false alarms. The Rio scale rates credibility. High scores notify agencies. Slow by design, born from past errors, this process builds trust. Operators feel the weight. Alex's patience tested. Lena's rigor shines. Raj's wisdom guides. Emotions peak. Frustration at bureaucracy. Resolve in method. Global relatability. Like communities verifying folklore, uniting diverse cultures in pursuit of truth. Tempo steadies here. Building anticipation. If verification intrigues, like, share, comment your favorite science myth. Transitions to history's lessons, enriching the tale. Step back to 1967, a misty evening in Cambridge, England, where Jocelyn Bell Burnell, a young astronomer, huddles in a chilly observatory, her breath visible in the dim light. Chart paper unfurls before her, scribbled with jagged lines from a radio telescope. Suddenly, a pulse, every 1.337 seconds, precise as a cosmic clock, cuts through the static. Her pulse quickens. She nicknames it LGM1. Little Green Men, a playful nod to the dream of alien contact. The thrill is palpable, a spark of wonder that could rewrite the stars. But soon, the truth emerges. A pulsar, a spinning neutron star, not a message, but a natural marvel. That discovery, born from hope and skepticism, unveiled pulsars as the universe's metronomes, forever shaping radio astronomy. Now, leap to August 15th, 1977, at Ohio's Big Ear Telescope, where Jerry Emmons scans a printout under flickering lights. A 72-second burst at 1420 MHz, 30 times stronger than the cosmic hum, screams from Sagittarius, right on the hydrogen line. Eamon's red pen circles it, scrawling, "Wow." A word that echoes into 2025, still unsolved, still sparking debates on X and in SETI circles. Was it a comet, as 2017 studies hinted, or something grander? The mystery endures, a beacon for dreamers. These tales are the pulse of radio astronomy, warnings that nature can mimic intelligence, interference, pulsars, or glitches playing tricks. The scientific response blends curiosity with caution, demanding confirmation to tame wild hopes. In 2025, with thousands of pulsars mapped and the wow signal unexplained, these lessons guide our operators. Alex in Ohio recalls his father's stories of the wow fueling his basement vigils. Lena in Berlin sees coding parallels, debugging false signals like lines of code. Raj in Melbourne links it to Vedic star myths, where celestial rhythms carry divine truths. Emotionally, the past resonates. Alex feels Eamon's awe, hoping his signal becomes a legacy. Lena, a woman in STEM, channels Bell Burnell's grit, fighting doubt with precision. Raj sees cosmic order, a modern myth unfolding. Globally, it connects. A Brazilian student might hear ancestral star tales. A Japanese retiree Shinto's reverence for the sky. The tempo slows, reflective yet charged, bridging past to present. If these stories ignite your curiosity, hit like and share with a stargazing friend. Comment: what's your favorite cosmic mystery? Let's transition to the operator's decoding dreams, where imagination dances with reason. October 2025, and the Discord channel hums like a global campfire, our operators, Alex, Lena, Raj, gathered to decode their cosmic riddle. The binary grid, 1,679 pulses, factoring into primes, 23 and 73, unfurls like a celestial tapestry. On glowing screens, a bitmap emerges. A spiral on the left, its arms curling like a galaxy's embrace. Not Andromeda exactly, but a universal symbol, evoking gasps. Alex leans into his Ohio monitor's glow. Lena pauses in Berlin, coffee forgotten. Raj in Melbourne feels the night sky watching back. The grid's edge reveals dots and dashes, 5 groupings matching atomic numbers. Hydrogen, 1, carbon, 6, nitrogen, 7, oxygen, 8, phosphorus, 15, life's building blocks. It's as if the sender whispers, "We share your stardust." Voices crackle on Discord. "This isn't random," Lena types, her code verifying chemical logic. Raj, voice soft, likens it to a cosmic greeting, a universal handshake. In the center, a cluster of marks defies chance. Perhaps DNA's helix, a viral form, or a mathematical constant like pi. Alex sees engineering precision. Lena, a recursive sequence. Raj, a mandala of cosmic intent. Emotions swirl. Alex feels his father's legacy in each pixel. Lena battles imposter syndrome with coder's resolve. Raj recalls Indian starlit nights where gods wove patterns. Globally, it resonates. A Mexican astronomer sees Mayan star maps. A Kenyan teacher ancestral creation tales. The group flags guesses as hypothetical, wary of seeing meaning in noise, yet the spiral, elements, and geometry scream intent. The tempo rises, a crescendo of wonder and debate. If this puzzle sparks your imagination, smash, like, and share. Comment, is it a greeting or warning? Let's unravel as we face the signal's daunting journey. Andromeda glows faintly, 2.5 million light-years away, a distance per 2025 data of 2.37 times 10 to the 22nd meters. Recent studies, like those in Nature Astronomy, peg its approach at 110 kilometers per second, with a 50% chance of merging with the Milky Way in 10 billion years. This signal, pulsing across that gulf, left when Earth's earliest hominids roamed, before tools or tails. A reply would take 5 million years round trip, dwarfing human history's 12,000 years. The operators grapple with this. Alex, in his Ohio basement, feels small. His childhood alien dreams now bittersweet, like a letter from a lost era. Lena, in Berlin, crunches path loss, 486 decibels at 1420 megahertz. Knowing only a city-sized or planetary transmitter could reach us, her coder's mind awed by such precision. Raj, under Melbourne's stars, sees epic journeys in Indian lore, messages crossing eons. The signal is a fossil, not a dialogue, cast into a cosmic sea indifferent to its fate. Globally, it connects. A Chinese student likens it to ancient skywatching, an African elder to ancestral voices. Emotions blend wonder, loss, and resolve. The tempo slows, grounding the narrative in human scale, building anticipation for truth's test. If this vastness awes you, like and share. Comment, what would you say across 2.5 million years? Now verification beckons. In 2025, the WOW signal's 72-second cry remains unsolved, debated on X and in SETI's halls. Amateurs like Alex, Lena, and Raj, linked by global networks, verify anomalies with rigor, their Discord a hub of shared dreams. Andromeda, a prime SETI target, challenges with immense barriers. No confirmed ET signal exists, per SETI's 2025 reports. Yet the question lingers. Are we missing messages for lack of tools or focus? The operators embody this quest. Alex dreams of a legacy. Lena unites voices from Seoul to São Paulo. Raj sees a spiritual search like sages seeking cosmic truth. Globally, it inspires. An Indian student joins a radio club. A Canadian retiree tunes in anew. With AI signal processing and arrays like the SKA advancing in 2025, the vigil grows, driven by evidence, not hope. The narrative closes with energy, an invitation to listen. If this journey moves you, hit like, share globally, and comment. Are we alone or just not listening right? Keep searching under the stars.